Good morning, good afternoon, good evening, wherever you are in the world. I'd like to welcome you once again to the latest episode of the NetOps Expert. And we are very happy to be joined today by GigaOM's own Andrew Green. Andrew is an industry analyst with the company and recently put out the Network Observability Radar report. Andrew, can you tell our listeners a little bit about yourself and your career?
Of course. Hi, everyone, and thanks, Jeremy, for having me back on. My name is Andrew Green. I'm a networking and security research analyst with GigaOM. I have a background in networking. I cut my teeth at a tier 1 telco here in the UK. Over there, I've done a bunch of roles, from radio network optimization to operational support system design to service management. And they actually played very nicely into each other because as I moved from one role to the next, I actually ended up using the tools I was deploying and so on. With GigaOM, I'm responsible for networking and security topics. You can't really have one without the other. Network observability is actually the very first report that I worked on with GigaOM. That was back in 2020. We are currently on the 4th iteration, having it just published a couple months ago. And we actually featured Broadcom in all of those iterations. And you can see their consistent position as a leader throughout those years. I'm actually doing my best to make the reports as difficult as I can and make them adjust to market changes and emerging technologies as we move from one iteration to the next.
Yes, as you mentioned, Broadcom has been named a leader for the last 4 years in the GigaOM Radar report for network observability, and we are very proud of that. I will say that I do agree that you are making it, you can say stricter, more detailed, but I have noticed the granularity to a lot of the questions you're asking, especially around metrics and natural languages. That obviously are applying to whatever networking is in the AI age, however that comes up. But please, can you define what you believe and GigaOM believes is network observability? Some people still think it's a buzzword, but why don't you give us your opinion on that?
Of course. So I want to first talk about observability and what it exactly means, because I don't think a lot of people know what's the difference between observability and performance monitoring. I also think that we should be careful with the words we're using so it doesn't cause any more confusion. And it's also something I care about, so I talk about it whenever I have the chance.
Mm-hmm.
Right. So the first take on observability is that it's next generation performance monitoring. And full disclosure here, that this is the approach I took a couple of years back when I produced the first iteration of the report. I think it's not necessarily bad from the way we define the report, because we also wanted to have a report that reflects what customers are actually using today. But it's a pretty simplistic approach, and there are some differences. And the proper definition of observability that I've been seeing people use, they essentially borrow it from control theory. And I have it right here. I'll read it out. So observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. And I read this, and I was thinking, I don't really get it at all. And I didn't get it for a couple of years, actually, until out of all places, I found somebody on Reddit that said something very relevant, and it finally clicked with me. So I want to make this analogy to kind of give you an intuitive understanding of what observability compared to performance monitoring means. So let's say you have a industrial machine that bakes cookies. You just chuck all your ingredients in there, your flour, eggs, milk, and so on, and you end up having some cookies. Observability would essentially mean looking at how the cookies turned out to tell whether something is wrong with the system. So, for example, if you take a cookie and it's burnt, you can probably infer that temperature might be set too high, proportions are not right, instructions are not right, or anything like that. Performance monitoring, on the other hand, would look at something like internal temperature of the oven, moisture, pressure, and so on. But just because you look at the temperature of it, it doesn't mean that it's actually producing the output that you expect. Now, going back to the thing that I read on Reddit, it was essentially a engineer that was saying he was looking to monitor some ephemeral containers. There was an engineer that was talking about this observability concept, and he was essentially saying that he had some services running from containers, and that the service degraded, but because the container was ephemeral, it was no longer there for him to investigate. So how do you investigate something that's no longer there? You have to look at its output. So he had to look at the logs it produced. Even though the container was not there, he did not know what infrastructure it was running on, it did not know its configuration and so on. So to understand why the service degraded, he had to look at what the container produced. And this is essentially what observability is about. If the system is ephemeral, it's not there anymore, you still have the output it produced, and you can look at it to understand its behavior. So for example, if you were to take away that industrial machine, you're not able to monitor its temperature and moisture sensors anymore. You only have the outputs to look at. But if you look at the cookies and they're not right, then you can infer that there was something wrong with it. Okay, so that's my take on observability. The proper way of looking at it is if it's a system that produces logs, metrics, and traces. Logs are essentially those outputs that we talked about, which are independent of the system it produced. And then you also have metrics and traces, which are a bit more general. To apply this to network observability, especially in the context of monitoring a system end-to-end and solutions, you still have to have network performance monitoring features. You have to be able to look at CPU usage, bandwidth, link utilization, and so on. But you also have to be looking at the logs, metrics, and traces that a system produces. For a solution to be full stack and qualified in the report, it must also be able to monitor and observe different types of networks. And this essentially says that I can monitor stuff that's within the four walls of my data center or my company. I can also monitor stuff that's in outsourced infrastructure, as in cloud services, or perhaps edge services. I can monitor unmanaged networks, so requests that I'm sending to end users or across the web that are not I don't have any control over. So I essentially end up having a solution that can monitor all the network traffic, regardless of the type of infrastructure it is, physical, virtual, outsourced, non-outsourced, and so on.
Excellent. And so what I'd like to do is later in the broadcast, I'm going to remind our audience about the definition. You know, obviously you say data is very important for network observability, different kinds of data, performance monitoring, but extending that performance monitoring across traditional and or software defined networks, and even beyond the edge of your networks into unmanaged networks like ISPs and cloud providers. So thank you very much for that. I do believe a lot of what the definition around observability is from various industry experts like yourself. The foundation of it is data. You know, the collecting the right data and utilizing it across, just like you said, different network architectures, multi-vendor, unmanaged or managed networks is the core to a successful observability solution. So let's talk about what you're seeing in the industry where there may be lacking capabilities and features from vendors to be considered a full stack observability solution.
Yeah, absolutely. So there are two aspects that I notice there's a lot of variety between vendor capabilities, and those are validation and then monitoring ephemeral resources. I'll start off with validation. So validation essentially means, does the system perform as intended? And the type of stuff that we evaluate when we look at evaluation is, for example, can the solution correlate performance degradation with configuration changes? Am I able to generate synthetic traffic to see how the network behaves without actually needing to have real user traffic? Am I able, in case of a degradation, to roll back to the previous stable state, and so on? So this is a feature. It's very hard to get right, but I also think it's very important in large organization, especially those with complex change management processes, that whenever they bring in a new service, expand the network, expand to another cloud, decommission something, and so on, that performance is not going to be affected. And no matter how much you do your due diligence as a company in very complex environments, it's pretty much impossible to get it right if you do it manually. So you still need to have this observability tool that can validate that what the processes you've been going through does not have a negative impact on performance.
I'd like to tell a quick story around that validation. So we rely heavily on our validation capabilities within the AppNeta solution to do just that. And what that is I'll give you a customer example. A medical insurance company, very, very large here in the United States. The SD-WAN team deployed a new SD-WAN architecture, and they weren't getting the amazing metrics and performance they expected from it. And what the NOC team did is utilize the validation capabilities we have to look at the entire network path that the SD-WAN application path consisted of, and immediately found a core switch and where that infrastructure was plugged into set at half duplex. That was immediate, validating. Obviously, at every hop, is that device in the entire network path performing optimally? And they were able to identify quickly for the SD-WAN team that obviously one of those hops, a core switch, was not configured correctly for the SD-WAN solution to perform optimally. So definitely agree that validation is key to network observability, and even validation before production, right? I mean, SD-WAN architects can design and test in a lab what the SD-WAN application path will look like and how robust it's going to perform prior to production. And then obviously when they move it into production, it's continued validation over time to make sure users are getting an optimal experience. Do you agree with all that?
Yeah, I absolutely agree with all that. And it's something that I've been exploring in this last iteration of the report. I classified this as modeling. It's essentially the solution's ability to capture how the network is architected and then simulate what changes to that architecture is going to have on the overall performance and behavior of the network.
Mm-hmm. Yeah, it's very exciting tech and capabilities that I never used when I was running data centers, and maybe you too. We didn't have that. We did everything manually, just like you said, and then you waited for something to break. So we don't have the luxury nowadays to wait for something to break. We got to make sure it doesn't break before we even put it into production. So definitely, things are definitely different than they were back in the 90s and 2000s running networks. And speaking of which, because on every NetOps Expert podcast, AI comes up, especially for networking and network operations. Maybe it's another buzzword. Who knows? Tell me what you think the impact of AI is going to be on networks and network operation teams.
Okay, so I always look at AI in two ways. First, you are a consumer of AI services, and then you are a provider of AI services. So if you are a consumer of AI services, it essentially means that I can use large language models and other types of AI products to help me do my work as a NOC operator. And for example, looking at large language models, because it's something that could have been immediately useful with the proper guardrail mechanisms and so on. For example, I can write queries in natural languages to produce reports, or I can define configurations in natural languages and get a YAML file or anything like that. So that is the perspective of me consuming AI services. Also, within the whole AI umbrella, we have machine learning as well, which can be used for forecasting traffic and so on. So it's not just large language models; it's a whole umbrella of products. The other bit is you are a provider of AI services, and this will become increasingly important as more organizations start developing AI products. And specifically, I'm thinking about how can network observability monitor AI data centers. And by AI data centers, I mean purpose-built data centers that have GPU meshes that are used mainly to train AI models, not necessarily infer, because infer, it's not the same beast as training an AI model, and it's a whole different kettle of fish. And by that I mean that in an AI data center, you have one-to-one subscription mechanisms. You cannot oversubscribe because bandwidth utilization is typically 100%, and any kind of degradation would have a knock-on effect on overall job completion time. So it's important to make sure that the network is not a bottleneck for training AI services. And it's also, how can I have a tool that can allow me to see whether there are any of those choke points in the network that I can reach up to 100% utilization, that I have the right configuration. I must be able to monitor leaf spine configurations. I must be able to see both virtual and physical infrastructure and so on. So there's a lot to do with AI in networking, but I mainly classified it in those two areas. And looking in the real world, I expect most to be part of the first classification, which is mean how can I consume AI services to make my job simpler as a network operator.
Yeah, I wanted to ask you, I had a conversation with Greg Farrow from Packet Pushers maybe last week, and he was all over the back end. So AI is never going to work unless the network infrastructure supports it at the speed AI demands. So, I mean, this is a whole nother topic for a podcast, but, to think about, if there's packet loss, packet drops during this, inside this GPU mesh where they're teaching the algorithms, and all these GPUs are synchronized and they start crunching data. When they come back to synchronize again, if any of them had any type of packet loss, their calculations are going to be off. So, solving nanosecond packet loss detection and fixing it seems very far in the future. I don't know if you have any comments on that.
Not necessarily having comments, but I obviously agree with what Greg was saying. And yeah, that's exactly right. I also produced the data center switching radar report, where we look at providers of data center network infrastructure. So it's something that I've been looking in quite a bit. You have to employ a bunch of techniques like explicit congestion notification. You have to be careful with stuff like what was it? Load balancing. So load balancing can really mess up the order of packets through the network. So you have to be very careful with the types of load balancing that you're using. And then you also have to be aware of stuff like InfiniBand and RDMA over converged Ethernet. I think as long as it's something that is IP based, most people will be more comfortable with. But if you look at non-IP based solution, that's another part where you have to not only evaluate the networking solution that you're deploying, but also the observability solution that you're deploying.
I'm sure you'd agree with me. There are parts of AI down the road that will not tolerate what we tolerate today from network performance. A little bit of packet loss here, some latency there. Those things cannot happen when we're teaching the algorithms to do certain things every single time, but without, I think you and I have had this discussion before, data. If you have 9 out of the 10 pieces of data that you need to, tell someone what the last week's network performance was for the company, that 10th piece of data could be very important to how that report or the output looks. So I'm sure we'll figure it out down the road, but you do mention this low-hanging fruit use cases. So do you believe we're not far from a NOC operator coming in to work one day and saying, hey, my NOC bot, where should I concentrate on, or where should I focus my attention this morning? And then, it looks through the data and tells him, hey, I saw some spikes in utilization in the Seattle office. You may want to look into it. Do you think that's a use case that may be closer to us than further away?
Yes. And the reason why I'm saying that with relative confidence is that it wasn't too long ago when I would show up in the office and then I would open up my CMDB spreadsheet, realize that I cannot see devices on my CMDB spreadsheet, sending emails to get the right one, ended up deciding I'll delete everything and have to build it again from scratch from multiple sources of truth.
Yeah.
So those were a fun couple of weeks.
I'm sure. That brings back horrible memories. I'm sorry.
Yeah, and even stuff like if something goes wrong, and then I was hearing other people talking in the office about something impacting me, then I said, okay, then it's not my responsibility. I'm not going to look into it because it was something downstream or something outside of my area of responsibilities. So considering the luxury that network operation centers have today with modern tools and so on, don't think we're too far off from automating as much as we can from the NOC activities. It's also a double-edged sword. So I don't think that we're going to get full autonomous network operation centers. I don't think that is the point. Yeah. But there are a lot of low-hanging fruit, as you were saying. For example, if something would require a self-heal mechanism, such as just restarting a device, that can save a lot of time and a lot of money if it's just done automatically, rather than somebody actually having to detect it, investigate it, come with a solution, and then perhaps even sending out an email to an outsourced NOC so they can do it on their behalf or something like that. So having NOC bots is definitely a nice goal, but it's going to be dumb NOC bots, essentially.
Oh, yeah. We got to teach them, right? I mean, if we can produce a report on the last week's top talkers or last night's top talkers or, last week's high utilization network devices, if we can produce a report on that, we can teach a NOC bot to tell us what the answer is as well, because it'll just it'll produce report itself. Yeah. Well, that is exciting. I do believe that I do believe you're right. We can't automate everything. It's too critical of infrastructure. Personally, I don't think we're ready to automate everything. Being hands-on with our network sometimes is very important, especially for human validation. Right? We can trust but validate. That's what we talk about at Broadcom. You architected this SD-WAN, but can we validate every device at every hop is optimal? trust, but validate. So I think that still is a big part of running networks today.
Which ties very nicely with the validation metric that I was talking about a bit earlier.
That's right. Well, I'm going to bring that up now. So, listen, I am going to plug Broadcom, and I am extremely proud for 4 years in a row that we've been named number one. I believe that is not only a team effort across the entire product team here at Broadcom, and some of that extends back to the CA days, but also the innovative ways we are integrating and building new use cases with other parts of Broadcom, especially the chipset side, especially the beyond the edge network observability solution we purchased a few years ago called AppNeta that brought us those validation techniques. We've been collecting, I believe, the most crucial amount of data for years now, because the solution was built for telecommunication providers. So you need high scale. You need a lot of data to correlate quickly. You need alarm noise reduction. Actually, let me stop there. You tell me why Broadcom was named a leader again 4 years in a row. What do you see as setting us apart?
Well, I guess the mechanical answer to this one is that Broadcom has scored highly across all the key features that we have defined. And we look at stuff such as network discovery, traffic analysis, as I said, validation, security observability. So, for example, can the tool monitor security infrastructure like firewalls and so on? The non-mechanical answer would be that as I've been writing those reports and essentially making them more difficult, right? There were very few items that I found through my research which Broadcom was not meeting, and those can be, for example, new stuff, but it can also be capabilities that I haven't captured in previous reports. And for example, AppNeta, I think that was a great acquisition, and the more I'm writing these reports, the more applicable it is to a lot of the features that I'm defining. And there's also new stuff that I'm seeing Broadcom come up with. And I had a couple of them written down. For example, volatility analytics, and then monitoring policies. I think monitoring policies is actually a very good one because it's a infrastructure independent way of monitoring how a service is performing. And I think that is not only a good user experience, but a good shout overall for a solution to implement.
Yeah. I can't tell you how excited we still are. And I think it's been like 3 years since we bought the AppNeta solution. And it extends what we've been doing from a full stack solution inside of the four walls of the data center and extends that out to unmanaged networks like ISP and cloud. So really, really exciting. And I will tell you, and I know you would agree, our current network observability customers who had not adopted or hadn't heard about AppNeta yet, when they do hear about it, Andrew, they love the mean time to innocence, or mean time to insights, as some people call it. That, like I told you, that healthcare insurance company, and they were able to find a half duplex setting on a switch. I mean, again, that happens in minutes once they turn AppNeta on. So can you imagine if a customer, I know of a story of a financial services company here in the US who hosted financial data for other companies. And one of those customers called and said, I can't get to this app or this data inside your data center, and complained and complained and complained. And the NOC team at this financial data center couldn't figure out what the problem was until they deployed AppNeta and found that the customer had a misconfigured F5 load balancer in their data center, at the edge of the start of the network path, right? The edge of their data center. And this type of innocence is really making a lot of folks out there, especially network teams, extremely excited about the capabilities and solutions from us and what we plan to deliver in the future.
Yeah, and actually want to follow up on this. My experience having been on both the network operations and then the product management side of it, when you start looking at, especially in telecoms, financials, investing in a tool that can prove, in a sense, is a very good return on investment, mainly because you have a set of service level agreements that you have to adhere to. If you break them, you have to pay service credits, essentially. So if you have a way of proving that you have not actually broken the service level agreement because it's out of your responsibilities contractually, then you're also going to be saving a lot of money on those service credits, which is essentially just money down the drain, especially if it's not your fault.
Well, listen, Andrew, again, I appreciate the collaboration with you. I appreciate the partnership. I appreciate your expertise in the industry. I wanted to give you just a minute or two left to talk about any research projects you're working on, anything you want to plug that our readers should be downloading and reading.
Of course. Well, we have a full catalog of research that myself and my colleagues have produced at GigaOM. It is behind paywall, but as far as I'm aware, you can have a free trial, and we cover all the enterprise networking goodness, essentially. So for myself, you can find stuff like network observability and data center switching, cloud networking, which is a good one, container networking, which is something that I spend a lot of time working on because it's very hard to get exactly right. And from that container networking report, I actually pulled and added it into a bunch of other reports because it's such a new, complex, and important topic, including network observability. And I actually forgot to mention, because earlier in the podcast, we mentioned what are the things that not all solutions deliver. And I mentioned validation and monitoring ephemeral resources. And those ephemeral resources are those containers, microservices, and so on. So when you work with those types of technologies, can you integrate with stuff like container networking interfaces? Can you ingest Kubernetes logs? Can you make sense of those Kubernetes logs? Because what is cool in that sense is that the network becomes a part of the application. So you can have a distributed application without having the network. And the DevOps team are doing some of the networking responsibilities as well, but they don't have the expertise or the granularity like other network observability tools do to understand how that actually behaves, not just within a cluster or even a multi-cluster environment, but in the whole production environment.
Excellent. Really, really good analysis of the networking space. Again, I really appreciate you being on with us, and I always appreciate your knowledge and expertise in the industry. It helps us continue to design solutions that not only our customers appreciate, but consistently allows us to be ranked at the highest when it comes to these types of reports. So Andrew, once again, thank you so much for being on the NetOps Expert. And I want to thank everyone for listening today, and check out the latest NetOps Expert on our podcast and YouTube channel.